Okay, all right, thank you. So first of all, thank you all for attending. So I know there's a quick intro, but I'll just go through that again, I suppose. My name is Sachin Pegavewardena, and I'm the founder of DeepSchool.io. DeepSchool.io came out as a project of where I worked as a data scientist. The main idea was for me to teach software engineers how to do deep learning and from there artificial intelligence and get that into the pipeline within the company, right? So in terms of my personal background, I started off doing my undergraduate in electronics engineering, and then I did my PhD in machine learning. But really what I want to emphasize with today's lecture, and obviously through my deep school thing, is that you don't need to be doing a PhD anymore to be a specialist in AI. It's actually gotten a lot easier to implement these days. So, so before we start, I just want to share some good news that I got this past week. So the first thing is that I recently passed the 1,000-star mark on GitHub. This is quite significant because it's usually only the best software, open source software repositories that get this much stars. So you like a certain repository if it's a good thing. And the second thing is one of the articles that I wrote. It came in the top 7 in the past 30 days of KD Nuggets. So KD Nuggets is the leading data science blog in the world right now. It's not quite a journal, it's nowhere near that actually, but the others. Okay, so today we'll be talking on a wide range of topics related to AI. So I will, sorry about that. So I'll start off by introducing what neural networks, or rather deep learning, is, and then I'll go on to some use cases, applications, in this case, recommendation systems, self-driving cars, medicine, and then we'll talk about one of the hottest topics in deep learning right now, which is called reinforcement learning. AlphaGo, if you've heard about it. We'll talk about the overhyped and sensationalized general AI, which is what a lot of people are scared of. And finally, I'll talk about how to practically use AI within companies. Okay, so let me just give you a quick demo on what machine learning is. Oops, sorry, not that one. Okay, so what we have over here is we have an input and then we have an output, right? So I'm going to be training some examples. Okay, so it's going to give me that output right now. So right now there's only a single class. It's not really doing much. But let me show you this. So now I'm going to put my left hand up and then do this thing. And then we have the second class. But what's interesting is, so if I put my hand down, we go back to that. But what's interesting is it doesn't quite recognize what the difference between your left and right hand. Yeah, so everyone with me so far? So the next thing that I'm going to do is I'm going to train my model to try and understand what right hand is. Okay, so right hand, I got my third class. Put my left hand up. Okay, so it's, okay, there we go. It's obviously not perfect, but if I do put my both hands down, you end up in the first class. Okay, so in a nutshell, that's what machine learning is. You have your inputs, the outputs, and then in the middle is where the machine learning or the deep learning comes in. We're trying to, essentially what you're trying to do is you're trying to learn a mathematical function that will, okay, I'll close this with this to get it going. So essentially what you have is you have a mathematical function that you're trying to learn that maps your inputs to your outputs. Okay. And this is very different to how mathematicians do it. So we don't spend that much time trying to figure out what are the best conditions. The main idea is that we train it on a lot of data. Okay, so I suppose the first question is, what is AI? It seems these days everyone has an opinion on what AI is. So I will do my best to separate fact from fiction. We'll be talking about self-driving cars, robotics, advances in medicine, to the lesser known aspects of AI. Okay, so the question that you might be asking is, how is this different to querying from database? So if you think about the example that I just showed you with the image of my face, the problem with having a database that says this image corresponds to this label, the problem with that is that there's so much variation, right? So if I move to the left to the right a bit, there's going to be so much variation. What label are you going to assign to this new image? So there's this concept of being able to generalize to understand that this is the left hand, that's the right hand. It needs to, like if I move my left hand a bit more to the left, it's still a left hand, right? So it needs to be able to generalize. So it needs to be able to generalize what it does in machine learning. So then the next question is it just statistics? Yet another data analysis tool. Machine learning certainly did borrow a lot from statistics to start off with, but machine learning, in my personal view, has a lot more to do with computer science than statistics. Right? So and there's obviously maths that comes into this. My main argument for machine learning versus statistics is that, for starters, computer scientists compared to statisticians actually get things done. If you give them a problem, they will solve it. Whereas statisticians, on the other hand, they'll be stressing out, trying to find out what the best model is, which variable is significant. Whereas what machine learning is doing is that they're just plugging all possible models in there and just letting the raw compute power figure out what the best model is by itself. In fact, there's this whole idea of combining models as well. Okay, so this brings me to deep learning, a subset of machine learning that is currently the reigning champion. Currently, and I do want to stress the word currently, the reigning champion in machine learning. So what's happened in the past decade for the meteoric rise in deep learning? Mainly it's two things. Firstly, the increased computational power. And I mean GPUs, not CPUs. And the second thing is large data sets, which was driven by cheap storage. So one reason that deep learning won over the other machine learning algorithms is this idea that it can read in data in batches. Okay, so it can deal with bigger and bigger data sets, whereas some machine learning algorithms, you need to see the entire data set, which usually doesn't fit in RAM. So coming back to this whole idea of computation power. So GPUs, if you can see this graph over here, the compute power, so in this case, flops, floating point operations per second, it's increased pretty much exponentially, right? So back in 2014, the maximum teraflops that there was achieved, so there's three teraflops at that point, okay, whereas all the latest, the best Intel architectures, they're still struggling to reach 500 gigaflops. Okay, and corresponding to this is this whole idea of CPU cores or GPU cores. Back in 2009, so what, 9 years ago now, the GeForce, the best, so one of the best GPUs had 8 cores in it at that point in time. Next year it came out with 48, and right now there's 3,000. So this in 2016 there's 3,000 cores. Okay, so each year NVIDIA at least tends to double the number of cores in there. Okay, so it's all about being able to parallelize when it comes to deep learning, and that drives machine learning to be more and more powerful. Okay, so let's talk about what deep learning is, or what used to be known as neural networks is. Neural networks, as the name suggests, was modeled on how neurons are connected in the brain. Personally, I don't like going into this analogy too much because the analogy is a fairly loose one. But nonetheless, here's how it goes. So we get some data, say an image of what we're looking at. In the brain, what happens is the neurons will fire if the light is bright enough. Okay, so there's this concept of thresholding. Okay, so after a certain threshold, the neurons will fire. Okay, and then you go on to the second layer, which will say, okay, is this a dog or a cat? And then you go on to the next layer above that, which will say, okay, so what should I do with this information? Should I pet the dog or whatever it is, right? So the main thing is that there's this concept of layers on top of layers. And that's what neural networks are. Okay, so the idea of deep learning comes from the fact that back when neural networks started, which is I think 1970s, there was only one, maybe two layers in there, because the computation was far too much for a process at that point in time to handle. Right? So because we have far more compute power, depending on what the problem is, people have gone up to hundreds of layers. Okay, so in fact, Microsoft, with one of the image challenges, which I might talk about in a bit, they have, I think, 120 odd layers in their architecture. Okay, so that's where the deep side of things is. So this guy on the right here, that's Jeffrey Hinton. He is considered to be the godfather of deep learning. Right? So not quite neural networks, but this neural networks is actually a really old concept. It was built in 1970s, died, and it came back up quite recently, mainly because of all these advances that was done. Okay. Okay, so computer vision was one of the first areas that deep learning made a huge impact on. What used to happen before was people used to come up with these really complicated mathematical functions to try and recognize, is there a pedestrian or a human in this image or not? Okay, so back in 2005, this paper came out called Histogram of Oriented Gradients. Okay, so it's an article on itself, but the essential idea is that it tried to focus on edges. Okay, so like when you took this image, there's a fairly standard mathematical function to get the edges. Okay, so don't stress too much about what the function is. And then they looked what angle are these edges oriented at. Okay. So it was looking at orientations, and after it got this feature set, it pushed it onto a standard machine learning algorithm, which said, yes, it's pedestrian, no, it's not. Okay. The good thing about deep learning is that you chuck out that whole feature learning phase. Right? So in this case over here, on the right, what I have is they trained it on a data set of faces and non-faces. It could be anything else. Right? So the task was to say, I need you, the computer, the machine, to say, is this a face? Is this not a face? Okay. So deep learning, all it did was it had the neural network architecture. It fed all this data in, okay, and it trained for a long time. And yeah, so these are the layers that it learned. Okay, and that's a key thing over here. It learned all these features. So in the first layer, it recognized that there are edges that are important. Okay, so the white and the black, they're different. Effectively, you're differencing things. The second layer, it started recognizing this is a nose, this is a mouth, this eye, and so on. And then finally, the third layer, the highest layer, it started recognizing faces. Okay. And keep in mind, these faces over here, they have not equal. They're not just copied images of the data that was input. Okay, so these are just general faces that it learned out of the data that it saw. Okay. I think I'm going to leave questions till the end. So is that right? Okay. All right. So right. I'm going to skip ahead and talk a little about general AI. So AI is defined to be a smart system that will one day think for itself without human inputs. One of the fundamental philosophical questions that I hear every now and then is, but can a machine feel? Can a machine love? usually my answer is a question in reverse. So what I say is, but are you sure that you feel, right? So isn't simply the fact that neurons are firing in your brain. And so at the end of the day, we too are machines. Regardless, let's talk about love. Let's talk about, does anyone recognize this symbol? No? So, this logo rather? It's Tinder. Everyone know what Tinder is, or do I need to explain that? Okay, so Tinder is a dating app. Right? So essentially what you have is you have faces, you swipe left or right depending on whether you like this person or not. So it could be Tinder, it could be RSVD, whatever the dating apps are. So I went to this talk given by a person who works for one of these dating apps. And one thing that he said was, as soon as you sign up, as soon as you fill in some of the basic details, they know who the best match for you is. In fact, they know who the perfect person for you is in the world. But of course, they won't show you that person for the first few months. And the reason is it's a business. It needs you to keep coming back over and over again. Right? So because of that, at least for the first few months, it will give you okay matches, it will not give you the best matches. So, so we're talking about recommendation systems, right? So dating is simply a matter of recommending who the best person is. Amazon and Facebook, sorry, not Facebook, eBay, they use this. So the algorithm that they use is something like this. So you have this massive table with the users on one side and the items that they bought. Okay, so in this case we have Ted, Carol, Bob, and Alice, and they bought the items A, B, C, D. Okay, so the blank was there if they didn't buy anything. So essentially what they do is they model this massive table as two matrices. Okay, so when you multiply this matrix, you get this thing back. And the task for the recommendation system is to figure out how many, so Ted hasn't bought any A items. How many items do you think he will buy, and therefore should I recommend that to him? Okay, so that's one question that Amazon and eBay ask for their business case. But at the same time, you can actually get a lot more information out of this. So they can ask which two people are similar. So is Ted and Carol similar? Because you have these numbers now, I can compare what Ted and Carol is as a person just by these numbers. Okay, so because of the buying habits, I have a model of who you are as a person. So this is part of what Facebook and Twitter or any other social media for that matter do. Okay, so this helps in serve ads to you, serve content to you as well. So as far as they care, you're just a bunch of numbers, which by the way makes you very predictable as a human being. This unfortunately also leads to echo chambers, which means, so on Facebook, when you read articles, you tend to read articles that you agree with as a person. Okay, so you're not, if you're leaning left, you would tend to read articles that are more left-leaning. So if you're a right-wing person, you will read a right-wing person, right? So unfortunately, this effect partially contributed to the 2016 election, the US election, right? So which led to Donald Trump winning. Because if you're a right-wing person, you're getting pushed more and more to the right. Same with the left, right? So there's very little left and center. So just quickly going off in a tangent, does anyone know what this sonnet? So this is Shakespeare's sonnet. Does anyone know what this is? Let me just zoom that in for you, if I could. I can't seem to zoom in. Right. Okay, ignore that then. Okay, so I'll just read the first few lines. So it goes, Pandarus, alas, I think I shall become approached on the day when, anyway, so that's a bit of a mouthful, so I'm not going to go into the whole thing. But does anyone recognize this Shakespeare thing? No? Okay, so even if you were a Shakespeare expert, you won't recognize it because it isn't written by Shakespeare. It was computer generated, right? So if you go to this blog post over here, it's actually an amazing thing where what this guy did is he read in all the Shakespeare plays and he trained it on the system. So trained it so that it will spit out one character at a time. So in the beginning, it was spitting out complete garbage, just letters, no spaces, nothing in there. And then slowly start to form words. So when I say words, it's like 4 or 5 letters, the space, the 4 or 5 letters, start putting periods. And right towards the end, so after training for 3 or 4 hours, this is the effect. Okay. Keep in mind, it's outputting one character at a time, which makes it even slightly harder. Okay, so it's not even doing words at a time. And what I have on the right is the deep learning model for it. Okay, so I don't want you to stress out too much about the detail, but the main point is it's just 6 lines of code. Right? So you don't really need to be that much of a specialist to do this. In fact, most of the work that I do, even though I'm a data scientist, is that I copy and paste. Right? So just need to go and find where these applications have been done before, copy and paste that in. Okay, so this guy did on Shakespeare. So I thought, why not do it on Donald Trump's tweets? Because he tends to tweet a lot, and there's a lot of data on that. So the way that I set it up so that I will put the first few characters, or the first few words, into my model, and I want it to spit out the next word. So I wrote the words "white supremacists are," and I needed it to complete the next sentence. And then the next word that it spat out was "friend." Okay, so this is essentially you're capturing the personality of the person within a model, within a chatbot. In this case. Okay, so right, so I'm hoping you recognize this one. Right? So it's been going on with these forever in Sri Lanka, as far as I know. So any AI talk isn't quite complete without self-driving cars. So the obvious contender in this space is Tesla. However, like in terms of technology, the capability to have a self-driving car, it's actually existed for the past 15 years. So if you think about it, it's really not that hard to make a car go down a straight line. Right? So all you have to do is accelerate, and if you detect an object in front of you, right? So using radar or whatever technology, it needs to decelerate. So that in itself is trivial. The hard part is things like turning corners, overtaking pedestrians, animals, and so on. So far, it's only Tesla who have made the self-driving cars that's commercially viable. So far, it's only just been research projects, so they can buy all these expensive radars and lidars, which you can be a little bit easier to detect objects. But even then, Tesla, so they got into a crash in 2016, right? So which killed the passenger actually while it was on autopilot. So it's far from being perfect. So self-driving cars so far isn't purely deep learning. There's roughly 3 components. So the first one is path planning, so getting from A to B, but also maneuvering around, say, a slow car. So it needs to get around that car. It needs to figure out what is the best path to go around it. The second one is control systems. Right? So you have to accelerate or decelerate, and the question is how much power, how much electricity do I give to that certain thing to give me the ideal output. And lastly, the third item is deep learning, right? So where you figure out is there obviously is there using the cameras, are there objects around me that I need to be aware of, and also it needs to predict the path of other cars as well. Say for instance, it's not just about it going forward. It needs to recognize, okay, this car is going forward. It's not trying to merge, therefore stay on the line. Okay, so these are some of the things that deep learning does in this space. Let me just play you this clip quickly. So this is TensorFlow. So TensorFlow is one of the biggest deep learning tools out there right now. And what it's doing is it's doing object detection. And this is a vital tool when it comes to self-driving cars. So in this case, it's detect pedestrians, cars, umbrellas. It's a general object detection API. Right? So this is all happening using TensorFlow. But the best part about this is it's only 2 or 3 lines of code, because Google or Facebook, whatever the research company is, they've already done this for you, and they've given you this open source library to play around with. And also there's things like this where you had to segment the surrounding area into cars, lanes, light poles, and so on. Okay, so the next section actually, one more thing. So the reason that self-driving cars isn't mainstream yet is actually, first of all, it's legal issues. Right? So there's legislation saying that cars haven't been tested enough yet to let them on the road. And by the way, Sri Lanka should legalize testing of self-driving cars. There's so much more to be gained right now. And actually, the ecosystem of how people drive in the subcontinent is actually quite amazing. But the way that you negotiate turns, that in itself is a PhD thesis, right? Just how we drive subcontinent. Moving on, so the second thing that self-driving cars haven't come to be more popular is the edge cases. And so the Tesla car crash that I just talked about, so that's a rare thing that happened, right? So in that particular case, what happened was there was a truck that was a bit taller than usual, and with the camera, sure, like in the camera, you can clearly see that the truck was there, but the way that it was trained, it's not looking above things, because the above area is usually the sky, right? So what it was looking at was like the ground level to try and see, is there an object over there? So because the truck was a bit too tall, it thought there was nothing, so it tried to go through, right? So it actually killed the person that way. But personally, I predict that in 20 years' time, that all cars will be self-driving cars, simply because it's too dangerous for a human to drive. And also on a side note, in 2010, there's 2,700 road deaths in Sri Lanka alone, right? So it's an obvious choice when it comes to changing legislation in Sri Lanka. Okay, so the question to the audience, is there anyone here tonight doing their A-levels? Or for that matter, have children or know anyone doing their A-levels? No? Okay, stop there. So as far as Sri Lankan parents are concerned, once you've done the A-levels, the main thing that people want the children to go is right up here, there's doctors, right? 2 engineers, 3rd lawyers, maybe, and somewhere down there, there's IT, right? So as far as I know, that's the current ecosystem. Now, if that's the way that you're thinking, I want you to go home tonight and tell your children to do IT. And let me tell you why. So when you think of doctors, you tend to think of someone trying to cure cancer or any other form of disease for that matter. But let me tell you right now that computer scientists are actually closer to curing cancer than a doctor would ever be. Okay? So the reason is simple. A doctor, a human being, will spend 5 to 6 years going to university, learning many different skills, and then perhaps reading a journal every now and then in a specialized field when they're trying to specialize. As far as deep learning is concerned, all it needs is a large number of labeled data sets that says this data contains a disease, this does not. Okay. It will form a decision boundary, or rather what we know as rules, to classify the data set into diseased or not. So just go to this picture that I have up here. So this was a competition for data scientists, and the task was to classify which images had a disease, which images didn't. And so in the end, the accuracy of the person who won was around 90%, I think. A specialist can tell between the two with 95% accuracy, roughly. So yes, there is a gap, and yes, so far right now, the specialist, a human being, is winning, but that's right now. Okay? And the second thing is we needed a specialist to say this is a diseased eye, this isn't, right? So you don't always have access to specialists. the main key idea of this thing is not the fact that deep learning lost to a human being. The key idea is that it took seconds to classify this image into whether it was diseased or not. And it's a lot cheaper to do it this way. All right, so one thing that humans are good at for now, and deep learning is only getting started, is this thing called transfer learning, right? So, for example, a doctor is able to look at some similar disease in one patient. Can you guys hear me at the back? No? Can't hear me? Okay, can you hear me now? Is it better? Okay, so so I was talking about transfer learning, right? So the idea is that you learn from one task, right? So doctors, they will learn to look at a disease, and then they will infer something about a different disease on a different patient. So this idea, so they've started doing this in deep learning as well, but it's very much in early stages. In fact, this competition, the people who won did end up using transfer learning in their applications, and that's actually how they end up winning this competition. Because the other machine learning or the other deep learning methods was simply taking too long to do this. All right, so reinforcement learning. So this is the most exciting idea in deep learning. So the idea is that you have an environment that you cannot control. So for example, the world, and there's an agent, say, suppose yourself, that needs to be taught how to maximize its rewards. Okay, so there's three concepts here: environment, agent, and a known reward function. The agent is the only thing that you can train to exist in this particular environment. So let me just show you this this video. So this is the game called Breakout. All right, so in the beginning, it's quite random. It actually, all that it knows is that this paddle can move left or right. It actually doesn't know the objective. Okay? So the only thing that it has access to is this function up here, which gives it the score. And all it wants to do is to maximize that score as much as possible. So the fact that it doesn't know the objective is really key. Right? All it's trying to do is maximize its reward function. So the more that it trains, the better it gets. It actually tries to hit the ball, because before you notice that it didn't really care whether it hit the ball or not. It was just moving randomly. But one really unique thing that it started to do was towards the end, it learned that the key to winning, or rather the key to winning this as quick as possible, was to drill around the side. So if you start seeing on the left-hand side, it's starting to hit the ball on that side. So you'll see soon enough. Yeah, so it starts hitting the ball right at the top. Okay, so if you're a player that just started this game, you probably wouldn't recognize that that's the quickest way to win, right? So it learned something that we didn't know, which is kind of unique. And also, so it's been tested in this in walking robots. Okay, so obviously it's simulated well, but the physics that's trained into this world are real, so that you can eventually put it onto an actual robot. Okay, so two-legged robots, you can see that in the beginning, yeah, it's just failing, but after 900 iterations of training, it's starting to learn. Okay? So yeah, so these are different kind of animals. So this animal has a tail on it. Okay, so yeah, eventually it starts to learn the way it's supposed to do. Right? So yeah, robotics. So robotics is starting to move into this area called reinforcement learning, rather than teaching it how to walk. Okay, so what used to happen was someone would code up, okay, move left leg, move right leg, left leg again, and so on. Okay. This doesn't know that. It's all it knows is that he wants to maximize the reward function. The reward function in this case is the amount of time that it stood upright. Okay. And just lastly, if you're a gamer, Doom. So this is actually one of the challenges to beat the first level of Doom. Yeah. So again, all you have is access to your support function, which is not showing here. But yeah. So the idea is that yeah, it's, to beat the first level without dying. Okay, so right. So has anyone heard of Go? So I'm sure most of you would have heard of chess, but has anyone heard of Go? Go is a similar. Well, it's a board game, right? So it's somewhat similar to, on a very high level. It's very similar to chess in that yeah, what you need to do is you need to try and capture regions. Okay, so this white thing over here, it's captured that region. So at the end of the game, what you need to do is you need to have more area than the other opponent. So that's the final task. Chess for that matter, it's like the computers have been beating humans in chess for at least like 15, 20 years, right? So that's not quite news. But the problem with Go is that there's far too many combinations that you can play. Right? So in fact, all the possible combinations of the board, it's said that it's greater than the number of atoms in the universe. Okay, so what does that mean? So what it means is if each atom in this world was a computer, it'll still take hundreds of years before you will solve Go to be able to be a human. Okay. So so the reason it made headlines was that it beat the current world champion 4-1. But to me, what was interesting was the pre-match conference by the champion who kept saying, a machine cannot beat human intuition, as if human intuition is something that could not be captured by a mathematical equation. And that's something that we talked about briefly before. And this is simply wrong. So it is bias that will lead someone to state that they are better than a machine that is trained to do certain tasks. So so coming back to the AlphaGo champ, he was humble in his defeat, but one thing that kept popping up in the post-match conference was the word creative in reference to AlphaGo's moves. Right? So for example, he would say move 37 was superhuman. So, but the thing is, there's nothing inherently human or creative about this thing. Right? So this is all just reinforcement learning. All it's trying to do is trying to maximize its objective function, which is to win. Okay. So yeah, so that's reinforcement learning. Let's talk about general AI. So I'm sure most of you are aware of the movie on the left, Terminator, but you should also watch this other one called Ex Machina. Right? So it goes into the idea of Turing test. So the risk of AI right now, or at least for the next few decades, is that a smart AI will start killing people. The risk is that a dumb person will equip an AI that can detect pedestrians and equip that robot to start shooting people. Humanity faces far bigger threats in the next 30 years than robotic overlords. There are two things that is a bigger threat for humanity right now. Number one, climate change. This is the obvious and the biggest threat, greatest threat of our time, period. There's simply no comparison. The second threat is Donald Trump pressing his small button, which will lead to nuclear Armageddon. So far, deep learning machines are programmed to do one thing and one thing alone. Sure, it's trivial to extend that to many tasks, but so far we haven't got a computer that will go looking for tasks to learn. Right? So there's always some sort of constraint on what it can learn. So the threat of AI that everyone keeps talking about is called singularity. So the idea goes something like this. Once a computer becomes smart enough, it can start learning new tasks and skills without human input. So through the internet, it will have access to vast amounts of data and it will continue to improve itself. And this will happen in an infinite loop. And this will happen to the point that it's far more intelligent and capable than humans. That is what singularity is. Okay, so this will happen someday, but perhaps not for the next 30 to 50 years. Singularity in itself isn't dangerous. Okay, so there's nothing that will say it's going to be a war. What's dangerous is if we start competing with these AIs for resources. Personally, with intelligence comes compassion, not greed. But saying that if humans were to instigate war, just like AlphaGo, they will lose, and not just 4-1. Okay, so enough about deep learning and reinforcement learning. So let's talk about how AI can be implemented in the workplace. So these are the 5 concepts, the principles of this company called Atlassian. So this was a startup that quite recently got into the billions of dollars. It's got 5 concepts in there. So the first one is open company, no bullshit. Right? The second one, build with heart and balance. Don't screw with the customer. Play as a team, and 5, be the change you seek. Right? So why am I bringing this up? I used to work as a data analyst at a company that was very close. There's a lot of people that was trying to protect their jobs, a lot of resistance sharing data and information. I remember there was one report that I had to do on Monday morning at 10 o'clock each week. Right? So, and I do mean each single week. And literally just had to press run. There's nothing else for me to do. So I asked, why don't I just productionize this? Why don't I automate this whole process? And his response was, if you keep doing that for every single job, we will all lose our jobs. Right? So yeah, so that was that company. I also tried to introduce machine learning to some tasks, but again, there was unnecessary resistance. The point that I'm trying to make is it's usually the younger generations that come up with these exciting ideas, have fire and passion in the blood. And then you have management of these large companies that will come and quickly quench that fire and go, get back in your box, do what you told to do. Right? So my message is this: let people fail and fail fast. Moving on, companies like Google, Facebook have made the companies AI first. Two years back, it used to be mobile first, right? So things have changed quite significantly and quickly. So of course, these companies, big companies, they have the resources, the budget, the money to train up their employees. But the way that it is right now, you don't need that kind of money to train up their employees, right? So deep learning has gotten a lot easier to do. 4 or 5 lines of code, which I just showed you, was enough to get you a neural network. There are so many free courses out there, right? So including my Deep School project, Coursera, Udemy out there. And just as a side note, I'll be quite surprised in 20 years' time if all these beginners still exist, right? So because the main thing is the problem with traditional universities is that there are some horrible lecturers out there who don't know how to teach, nor do they care. And once you have online university, you have the best teachers out there right on your doorstep. So coming back to implemented deep learning, if these options that I just mentioned are still costly for you, Amazon, Google, Microsoft have released most of the research as APIs for software engineers to use. Data analytics is a 2-step process. You need to get the data that is relevant to your business, which isn't always a trivial process, especially if most of the data that you currently have is written notes. So you do need data engineers to build the necessary architecture and systems to capture this data. And then the second thing is you need to analyze all these massive amounts of data that you get. So one reason that you need to have a data analyst or scientist working somewhere on your pipeline is, if you think about it, all businesses have a domain knowledge on some specific area, a very specific area usually. They look at all the sales that they generate and use that information to change the production process for the better usually. What would happen if you don't have a proper analysis somewhere along this pipeline is that it will lead to hunch-driven decisions. Whereas what you really, really want is data-driven businesses. So to summarize everything that we talked about tonight, first of all, AI isn't out to kill you yet. Second thing, as AI and deep learning advances, people will lose jobs. And I don't mean just the laboring blue-collar jobs. But what people don't realize is the enormous potential and the opportunities that will arise from AI. For starters, people will start living longer. Consumer products will become cheaper. Third, embrace AI, or at least analytics, into your software pipeline. And just to finish off, last but not least, computer science, not medicine. Thank you. Are there any questions? Yeah.
Two questions. One is regarding Go.
Yeah.
What can I do by the algorithm? Whatever that consider Go. But I have read is that unlike in Go something that we establish, that same method can be used for other applications. say, production of new drugs or normal treatment.
Right.
Things like that. It's generalized.
Yes.
Okay. That will be fun.
Right.
The second one is a more critical question. Will AI or deep learning human beings generalize? And it's not a case of man versus machine. It may be that a few people or like organizations control the world.
Okay. So the question was, first of all, can the lessons of AlphaGo be generalized? Is that correct? And the second question. Yes. Yeah. So can be generalized, and the second question was on the ethics of man versus machine. So I will answer the first question about generalization. So all the stuff that I showed you on reinforcement learning, it was more or less one key concept. Okay, so the key concept is it wants to maximize its reward function. Right. So if you think about it, the reason it's such a hot topic is it's reinforcement learning is all about game playing. And if you think about it, you can extend that to the world as well. The world, you as a human being, your goal is to live as long as possible. Right? Now, coming back to the technicalities of this thing, yes, it can certainly be generalized. So one area that I probably will be researching in the next few months is how to apply reinforcement learning to finance. Right? So if I can manage to figure out what, so usually what happens is you have these specialized people that will say, okay, I have this portfolio of stocks. I want to invest in this, and this kind of stuff. Okay? But at the end of the day, you have this function. So you have this reward function, which is the amount of money that you get, and all you want is to maximize that. Coming to medicine, I'm not entirely sure reinforcement learning is the application, but certainly just this usual deep learning, just the basic deep learning can be applied, because for the case of trialing drugs to see this worked and this didn't, right? So it's a binary classification problem. So it certainly can be used. The question is, how do I twist and turn that deep learning model to fit into this data set? Okay. So there are some differences, but the differences are small compared to what used to happen, where people actually really cared and stressed about the math side of things. Right? So whereas I feel now deep learning is a bit more of a software problem. Finally, the ethical question on whether humans will become irrelevant. Yes, right. So we will, but anyway. So like I could probably talk about that as a different lecture. But in summary, it's just something that we shouldn't worry about right now, right? So people are talking about trying to regulate AI in the UK and stuff by bringing legislation. Right now, it's in time, because right now all we're doing is matrix multiplications, additions. So it's just it's fairly basic. So if you regulate them, you're saying you can't do multiplication, right? Which is when I say it like that, it sounds pretty dumb, right? So yes, you will need legislation, but that's like at least 20, 30 years down the line. So yeah. Go on.
Thanks,
Thank you.
I'm not
Sure.
neural network. Okay, and I have not part of computer science.
Yes.
Not worked with in neural network.
Right.
But I have had students who use them for engineering applications.
Right.
They bought out packages or
Yeah.
packages in the lab. They use them to optimize something or
Sure.
solve engineering problems. So even at that time, when I was around 10 years ago,
Yes.
so even at that time, there was a little bit of debate, argument among students about what is going on. Whether the data set, quality and quantity of data is that really what you want. Students today and understand no, the learning within the algorithm, the way in which those weights are set, the way in which the links between the neural network are the quality of the algorithm within
Perhaps that question is a silly one in the sense that maybe it depends on the application. Maybe for, I don't know, playing Go or chess or just driving cars, clearly the quantity and quality of data is very important. While perhaps in medical, you can't induce, you can't induce patients at hard time.
Sure.
You can't do one day.
Right.
Then, what's your comment or is it all
Okay, so I guess the question was, first of all, quality versus quantity when it comes to deep learning, and second thing, there are some applications where you can't get more data. Does that sound about right? Yeah. Okay. So so to answer the quality versus quantity question, for me, so for deep learning to work, generally, as a thumb rule, it's not always the case. You do need a large amounts of data. But when I say large, I mean so the course that I'm doing is all about trying to do deep learning on your laptop, right? So no cloud infrastructure. It's all about trying to do it in your local system. So it's quite a misnomer that you need like big data. So as far as quality is concerned, again, yes, it does depend on the application, but the way that what I feel is that the mistakes in the data, if you have a big enough data set, it's just going to get averaged over. Right? So the main thing is that you have proper labels in your data, and you clean it as much as possible. So yes, so far you do need to clean your data and do some basic transformations, but it's nowhere near the amount of feature learning that you do for regular machine learning problems. Right, and as far as coming to the medical problem where you can't induce heart attacks or comas at will, so yes, so okay. So the problem right now is that with doctors, they have all this domain knowledge on medicine, and they are able to combine all these different things in different areas to perform that surgery. So even then, they only have a certain experience that they can rely on, right? To go back in time and say, yes, I performed this surgery on this person, and therefore this is how this surgery should go. So they don't have an infinite amount of data. But what they do is that through the experience through life or through their time in college and medicine, they learn, they transfer their knowledge. Right? So that's one thing that deep learning is not doing just that well just yet, right? So I think that's one thing that DeepMind of Google is trying to do, just to combine knowledge across different domains into a brain, so to speak, right? Just so that you can answer general questions about different things. So it will come. It's not obviously it's not great right now, but it's certainly I can see that becoming the next, say, 20 years or so.
Dr. Satya, my name is Anomaly. We're going to do a quick series of questions,
right?
Trying to handle on. Now, artificial intelligence, deep learning, and all these things that we're discussing, they are new to the world, and they're actually new to Sri Lanka. So the context in which you gave the definition might make it's heavy, right? To me. I don't know about the rest of the audience. So I have to get this understanding clearer to them.
Yes.
Where is the best artificial intelligence application right now in the world? Where is the best application right now?
Anything to do with computer vision? That's
computer vision.
Computer vision. That's easily the. It's yeah. That was the first thing that deep learning started off happening, right? So through that, yes, it's.
Why is that? Why was it easy for artificial intelligence or deep learning to focus on that?
Yeah. So let me just quickly go back to this this problem over here. Right. So the question was, is there a pedestrian or not in that question? So the thing with images, right, is that it was easy to capture, relatively easy to capture compared to other data sets. It's always the same size when you compare things, right? So it's always a 250, 240 by 120 image. And the other thing is that I can augment this image. I can shift it a few pixels to the left, shift it a few pixels to the right, and generate a bigger and bigger data sets. Right? So in that sense, and I can flip the image. So if I flip the image left and right, it's still the same content. So in that sense, images was easy to generate more data, and therefore fed into neural networks just like that.
Okay, so 1989, 1990, when we were doing machine vision using C++,
right.
Is that different from deep learning and artificial intelligence that you are doing today?
So, okay, so machine vision is actually quite a large area, right? So there's a few problems in, so when you start off with vision, there were problems like, is there saturation in the sensor in itself? So it wasn't necessarily anything to do with learning as such. So there were hardware problems to deal with back then. So machine vision is a separate field, which haven't really looked into that much, but I don't think it exists as a big thing these days, because most of the camera problems, like capturing images, it's very much solved these days.
All right. Now, moving into the next 10 years, where will this science impact most in our day-to-day life? Or will it at all? I mean, can we see something significant that will be disruptive in our life in the next 10 years?
So the thing that's impacting you right now, as it is Google, right? So every time you do a search, all of that is going through some sort of machine learning algorithm. It's saving all your results, more or less. It's reading your emails. So Google, Facebook, that's an obvious thing that's happening right now. In terms of actual impact, I'm hoping medicine will become a big impact. Actually, no. Self-driving cars is probably going to be a lot bigger, because across the world there's too many deaths to count that happens because of human drivers, and that will go significantly down over the next 10, 20 years.
Now, coming back to the country, family generation, university students, and maybe even family engineers, where should they start? I mean, let's take a guy who is just finished A-levels, starts for research. He comes to the university.
Yes.
Now, our university may or may not have the level of advanced labs and this I do not know. But the question is, what exactly such a young man or woman should be doing, working on, to become good at this down the road when they are about 35 or?
Right. So okay. So for me, like, I obviously did a PhD in this area, right? But so I did a PhD in machine learning. But one thing I tell everyone these days is that we definitely don't need to be doing a PhD to become an expert in deep learning. In fact, it was after I finished university that I got into deep learning, which is a completely different field to machine learning. Right? So I started from scratch, and it was quite quick to accelerate. So yes, it takes some time to read through the material, and it is your time. But I just feel like the gains, the benefit that I got was enormous. Now, how did I go through it? Blogs, right? So it wasn't university. There was some free courses that I did on Coursera, and so I just started implementing. I think that's really the key word. So it's not enough to just read and just listen to a lecture. Just one, you need to be disciplined enough to go through the entire course. I think that's one thing that traditional universities have over online courses, because once it's online, there's really no reason to, unless you're paying, there's no reason to go back and study. We're not in a tangent there. Now, what was the question?
The question is, what should a young man or young woman just entering the university should be doing to get good at this science, maybe 50 years from now when they're running?
So the answer to that is code. Right? So keep coding. Come up with a pet project and just try to solve that with a given open source software that there is.
where would they go to learn this? You said you learn a lot of stuff online. Where should they go to?
Coursera.
Coursera, which is a book.
Yes.
Massive online open
Course.
courses. That's one of the websites that allows.
That's one of the websites, but there's also, like, I read blogs as well. So there's a big place for Medium. And they post, a lot of people across the world post their content over there, in coding and mathematics, a lot of areas actually. But yeah, so you just subscribe to whatever topics that you're interested in. You start learning from there.
Thank you.
Did you?
First of all, thanks for the lecture. My question is about the design. Any tools to management of things? Artificial intelligence based.
Sorry, I missed that. So
Traffic management.
Oh, traffic management, right. So this is an area that I'm personally interested in. I haven't applied deep learning in this space. I'm not entirely sure deep learning is the way to approach it. It depends on your application, right? So that object detection API that I showed you with all these people moving and putting bounding boxes on people, cars, and so on. China have used that, right, to say these are pedestrians. They're actually tracking people along. So one thing that you can say is, if a car comes to a stop, do you want to give it the green light or the red light, right? So the reason that I'm not saying it's a complete system is because the decision to give it the green light or the red light is a different system, right? So, and the machine learning does the detection part. Modeling the traffic across the country, now that I feel is a bit more interesting and probably a harder task, because there's a lot more data, and it's not entirely a solved problem, right? So and that might be more of a machine learning problem. I'm happy to talk about that to you afterwards, but yeah.
So nowadays, self-driving cars, maybe provided traffic.
So self-driving cars, they're going to have a different problem when everything is self-driving car, right? Because the thing is, like, there won't be a need to have traffic lights anymore. So right now, self-driving cars have to drive in a human world where there are traffic lights. People can cross the road at whenever they want to, and they need to predict how the cars are going to move. So they have this extra stress on the self-driving cars, all these other things. So self-driving cars can definitely contribute to the traffic problem, right? So to help solve it, but yeah, so that's not something that's happening right now. If there are no more other questions, so is there?
Thank you. I'm thinking of the future of this AI. There are a lot of developments in quantum computing,
Yes,
and quantum physics and computer science.
yeah.
It is physics are
Yeah.
How do you assess the impact of quantum computing on this area? Yeah.
Right. So I haven't read that much into quantum computing. So as far as I understand, it's just a super fast computer, right? So right now, the way that it will impact is training will just become so much faster. And once quantum computing becomes something that can be on laptops rather than on cloud servers or at university somewhere else, then that's when things start to get interesting, right? So for starters, there's all the problems that will come with being able to crack encryption. But then, as far as deep learning is concerned, yeah, so you can build bigger and better models to do a lot more things, do a lot more tasks. So that might be where general AI comes in. sorry, one more question. I'll come to you.
No, about the event you were talking about the feet that have got popular these days.
Sorry, what was popular?
The feet, the application, dating application.
Oh, Tinder, yes.
Yeah. And how does it collect the information from a user and display it on the other user? How does it make better signal? How does it make this better sort of all?
Right. Okay.
Because the information we should provide in that is very much less just the pictures and also some descriptions from the Facebook or so just
okay. So right. So that was a question. There's a good question. So the question was, how does Tinder gather information about you? Because one, there's only a limited amount of information. So yes, you can. If it was just images, you can do some sort of. So actually, what will happen then is that you have the information of them swiping left or right, right? So initially, the matches that you will get are completely random. Right? So there's no order, there's no reason as to why you get those people, just apart from the fact that they're nearby. As it learns, these are the kind of people that you're into, right? So again, even you're probably not reading the description, you're just swiping left or right. It learns these are the kind of people that you're into, right? So just from facial features. So getting detecting a face is a solved problem from 10 years ago, right? So once you extract the face, you can start learning on this face what are the certain things that you are attracted to. Okay, so because it has a data set that goes, yes, I like this person, no, I don't. Yeah, so yeah, I think.
Now, I think you mentioned on deep learning stock market.
Yes.
Say I think 3 areas: stock market, economics,
Yes.
and weather forecast.
Yep.
Even climate change a little further. Now, you have all these 3 components, and the relationships are could be complex.
Yes.
Because if I understand deep learning, only tries to reward function, optimize that reward function. But also there's a risk management. The stock market is not only risk management. How much deep learning can it predict the chaotic system? Predict sudden change.
Correct. Okay, so I guess the question was, how can it predict sudden changes in stock markets?
All 3 stock market economics, and it's related.
It's all okay. So it's all time series questions, right? So in time series, there's a particular thing in deep learning called recursive neural nets. And so people don't tend to model financial markets yet, just with deep learning, right? So they use a whole bunch of other tools as well to assess what they're going to be doing. So can it predict sudden changes? No. And again, so the reason with deep learning or machine learning for the matter, or statistics for the matter, is that you have a loss function that you're trying to minimize. Okay, so what they do is they're trying to find the signal through the noise. Okay, so if these spikes are rare, it's not going to model that well because it's just too rare. It hasn't learned that pattern. So there's practically no way, unless you have some external data set that you can augment onto this neural network, there's no way that you can predict the spike, which is essentially random. Okay, so and just to give you a quick analogy, random number generators, right? So if I make a random number generator and actually make 2 data sets of random numbers, the machine learning isn't going to do anything. Okay, so you can't predict a random number, no matter what you do. Okay. So all it's trying to do is it's trying to minimize loss, which might be some mean squared error if you know what that is. But what it'll do is so it'll give you a straight line right through the middle.
Just one thing. When you say random, sometimes, but not like random number. Maybe completely
Right.
random, but when that I have a pattern, maybe that suddenly might be something that you don't see a pattern. That's what you call random.
Yes.
Not true random.
Right.
Maybe that
Okay.
data set did not have it all.
If there's some external data set that can
We can
inform you,
theoretic system of, but they do have.
sure, and they do happen. So all you can really do is you can say you can quantify the error. You can say this is the maximum risk that I'm about to take. No, sorry, not the maximum. Okay,
So in that area is what you are basically saying. That is not strict predicting.
It's not the
Or
strength.
even, I mean, who are not, I read the theory. They say they discovered the Earth's humans did not.
Yes.
It's
Yeah.
completely different.
Yeah. So okay. So keep in mind that Go is different to usual machine learning, right? So Go is a game playing or reinforcement learning problem, whereas the other stuff is a prediction problem, which you have an input, you have a labels, whereas game playing all you have an input set which might be the environment, but it's a reward function. It's a bit more complicated when it comes to reinforcement learning, right? So so this is a long answer. I'm happy to talk to you afterwards. Background is in
we also have called intelligent coding that you can and it is based on the basic content. The other problem is finding the data to get basic condition that will give the result that you are looking for.
So what do you mean by the basic condition? So do you mean the prior?
Is actually different set of conditions that will generate the outcome that you want to make decision.
Right.
Days of data, you sort out and do that. Default, maybe that copy, you have now the how to do that. Instead of basic condition, you can always find a set of conditions you give a output with almost high probability.
Right.
89%.
Yeah.
So you try and you get some and you can actually generate that type of thing. I see. That one problem with coding is if there is sudden change where you subscribe to it. Today, they monitor or you use all sorts of like network using for lotteries, competition, and result. The capacity is not enough because every pattern is changing every moment.
Right.
And this causes problems.
Yeah.
So one of the problems is actually sorting out the data and the correct set of signals to make a proper decision.
Right.
You have to identify the set of basic conditions. Create those.
Okay. So I'll try to answer that as much as possible because I'm not entirely sure I understand it, but I'll talk to you afterwards. But so one thing that machine learning and deep learning does is that it tries to predict something on average. Okay, so what's the average output? So so that's not always a good thing. And in your case, when you get to these spikes, you can't quite keep up, right? So the system simply can't keep up. I wrote a blog post on this thing called quantile regression. So the idea is rather than focusing on trying to figure out the median or the average value, try and predict the extremes. So the 90th percentile, the 95th and 5th percentile. Let me just, sorry, that was about to die. Let me just finish up the presentation.